Example 1. Just before his first attempt at bungee jumping, John decides to buy a life insurance policy. His annual income at age 30 is $35,000. So he figures he should get enough insurance to provide his wife and new baby with that amount each year for the next 35 years. If the long-term interest rate is 6.7%, what is the present value of John's future annual earnings? In other words, how big of a life insurance policy does he need? And round up to the next $50,000. All right, so to solve this problem, we are going to use the present value of an annuity formula, okay? First thing we need to talk about is why this is the formula to use, okay? All right, so the first thing we need to realize at this is that this involves an annuity, okay? When you have life insurance and then, say, unfortunately, something happens to the person who has the policy, their benefactors start receiving regular payments out of this or from this life insurance policy, okay? So he wants to get enough life insurance so that if, something happens to him, then his wife and baby are going to receive $35,000 each year for the next 35 years, okay? So this involves an annuity, the regular payments of $35,000 yearly over a 35-year period. And furthermore, the annuity is being paid out, okay? You've got this, pretend it's like this life insurance account, and it would pay out this money, this yearly amount of $35,000 to the wife and child. Okay, so you have an annuity being paid out. That makes it the present value of an annuity formula. Okay, so you would write down this formula. Okay, and it's definitely more complicated than any of the formulas we've encountered so far in this chapter. Okay. All right, so here we go. All right, let's talk about what we're looking for and what the values of all the other variables are, and then we'll plug in and solve, okay? All right, so we're trying to figure out, basically, if you read like the last sentence or two, you're trying to figure out how much life insurance John needs in order to pay out $35,000 every year for 35 years upon his death, basically, okay? All right, so what this kind of entails. Okay, let's talk about what we do know. Okay, remember, P is the amount of money, the amount of each payment to the recipient. That's how you can think of the P value. So upon something happening to John, his wife and child would receive the money, and so each payment would be $35,000. So that's going to be your P value, okay? The interest rate is going to be 6.7%, so it's 0.067 in the calculations, okay? ILM, okay, so if you kind of scan through this problem again, we don't see the phrase compounded such and such in the problem, but the way you can decide your ILM value with these types of problems, if it doesn't say, you don't see that phrase compounded, whatever, how often are the payments, okay? The payments are going to be every year, okay? So the timing of the payments also should coincide with how often the interest is being compounded, okay? So remember, you have what I keep calling this life insurance account, and so the payments are being made out of this account to the wife and to the child. So they get $35,000 a year. The money that still remains in the account is still earning interest, okay? So if the payments to the wife and child are yearly, okay, then you can assume that the interest that's the money that's remaining in the account, it will accrue interest on the same basis, so on a yearly basis here. So ILM is going to be 1, okay? And then T, the annuity is going to be paid out over 35 years, okay? So we know P, we know R, ILM, and T, so that means we are looking for PV, okay? So again, if you read the last sentence or two, it's saying how much life insurance does John need, okay? So Again, once we plug in and get this answer, we will talk about how to interpret this answer, okay? All right, let's plug in. Okay, so we're solving for PV, which is probably the easiest variable to solve for of all of these in this formula. All right, so we're going to plug in our variables. So we're going to get 35,000 times, the numerator is going to be 1 minus 1 plus r over m to the negative. Make sure you realize for this formula the exponent's negative. So negative 1 times 35 all over r over m. Okay, so we have plugged into it. Okay, so we need to just plug this into our calculator, and that will give us the present value amount. Okay, so let me find my calculator. All right, so remember, we haven't seen this formula yet, but I've told you when we've looked at other formulas kind of for the first time, you always want to start with the most complicated part of the formula and plug that into your calculator first. So work your way from the most complicated part to the least complicated part. So if you look at this formula, inside the brackets is definitely the most complicated part. Out of the numerator and the denominator, the numerator is the most complicated, so we're going to start there. So I'm going to type in the numerator just like I see it. So 1 minus parentheses 1 plus 0.067. Again, if you divide by 1, you're going to get 0.067. But remember, you may have a number other than 1. Your m value could be something else. So just get in the practice of plugging in the m value here. So you would divide by the m value, whatever it is, close the parentheses, and then your exponent. Okay, either do it in your head, or if you can't, put it in parentheses. I'm going to put it in parentheses just to make sure that negative is taken care of. So I'm going to do parentheses, negative 1 times 35, close parentheses. This is the numerator. Okay, hit enter. Okay, then hit the division key, and we're going to divide by the denominator. Okay, again, I'm going to type it in as if we didn't have an m value of 1, just so you can see how to do it. All right, so we're going to divide by r over m, close the parentheses, okay? If you don't do the division in your head, you have to put the r over m in parentheses if you have an older calculator. Hit enter. This 13.38 ... is the quantity in brackets, okay? Now we need to multiply that by 35,000, so hit times. So it's going to take the previous answer and we can multiply it by 35,000, okay? And that is the answer. I'm going to go ahead and write it down, and then we'll talk about rounding. Okay, so we are going to get, let's write this down, $468,407, and then we'll talk about the rounding for the cents. Okay, so there you go. And again, this is our value for PV. It is a dollar amount, so we need to round it to dollars and cents. Okay, so you're going to round it to the nearest cent like we're accustomed to. Okay, so we've got 35 cents. You look at the number that follows, it's a 3. And so we are going to keep it 35 cents. Okay, so it's going to be $468,407.35. Okay, that is the actual amount or level of life insurance that John would need. Remember, you were asked at the end of the question to round up to the next $50,000. Reason being is, like in real life, you know, you don't buy a life insurance policy worth this amount. It's usually some even number, like $400,000 or $450,000 or $500,000. So that's why you were asked to round to the nearest $50,000. If you did round this to the nearest $50,000, John's going to need a life insurance policy of $500,000. Okay, I'm just mentioning that. Okay, we're actually going to talk about this number because this is the actual number. But if you did round like the answer or the question asked you to do, this is basically the amount of the policy that John would need to buy. Okay. Don't misinterpret this. When I've done this in class before, I've had students ask, well, does that mean I have to pay $468,407.35 and buy that, you know, spend that amount of money to buy my life insurance policy? That's not how it works. Okay. So if you go to your insurance company, this would be, you would be purchasing a life insurance policy of this value. Okay, you pay like a monthly fee, and that will, get you a life insurance policy worth this much. But this is not actually the amount of money that you're paying for it. So just keep that in mind. Okay. All right. So we went through this formula. Okay. We calculated the present value. Okay. Like I said, we're going to map this out so you can understand what this number means. Okay. We're not going to work with this, because this is the actual value that we came up with. This is in real life how you would purchase it. You would purchase a life insurance policy worth this amount. Okay. But let's talk about this amount and what it means. Okay. So on the next page, okay, let me get it. I have this mapped out. Okay. Hang on a second. Let me arrange this stuff. I have some columns here. Okay. Payment, beginning balance, deduction, ending balance. Okay. So I did this little table in Excel. Okay. So remember, if something were to happen to John, okay, he wants his wife and child to receive $35,000 every year for the next 35 years. So payments, I've got 1 through 35 because she would receive one payment every year for 35 years. And that payment under the deduction column, that payment is going to be $35,000. Okay. So basically what this little spreadsheet I created does, it's tracking how this answer we came up with, this $468,407.35 actually pays out this annuity. Okay. So again, I told you when I was trying to explain the meaning of the present value formula, okay, you want to think of this as the one lump sum that must be invested in order to pay out the annuity. Okay, so basically this is the one lump sum that, the insurance company would have to invest in order to pay out these equal yearly payments of $35,000 for the next 35 years to John's wife and child. Okay, so we're going to see how this works. Okay, all right, so what I'm going to do, okay, before the well, let's start from the get-go. Okay, so we calculated the amount of, the present value of this annuity. So we're under the beginning balance. I'm going to put that amount. So the $468,407.35. Okay, so that's the one lump sum that is invested, okay, by the insurance company to pay this annuity out. Okay, when this money is invested, nothing happens immediately other than it starts earning interest. Okay, the first payment doesn't happen for an entire year. Okay, and remember, it only gets paid out if something were to happen to John. Okay, theoretically, I'm just showing you, John may buy the insurance policy today and he may not, die for another 25 years or something. Okay, I'm just showing you with this, table, like how this present value amount actually works to pay out the annuity. Okay, all right, so this is the number we calculated, the one lump sum that we would have to invest in order to pay this annuity out. Okay, nothing happens immediately except you put the money in the account. It starts earning interest at the interest rate, which is 6.7%. Okay, it could not start paying out for the next year. So the money is going to sit there for an entire year since everything is being done yearly. Okay, so it's going to earn interest for the next year. Okay, and then after that, it'll start paying out. Okay, so basically 1 year passes, because I'm going to even write this here. This money sits and earns interest for a year. Okay, so a year passes from that initial deposit of that one lump sum, and we're going to calculate how much money is in the account now. Okay, so I'll